Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Hafizi bin Ahmad Azim. My metric number is AN190168. For case study, my part, I will present about case study number 2. So greeting to our lecturer, Dr. Hafiza binti Hassan. So let's go to the next slide. So for introduction, for this case study number 2, this case study related to our syllabus, which means at the chapter 2, uh, pressure and fluid static. So for introduction, we try to investigate the influence of wind on the tall building. A wind tunnel is carried out. So the engine initially require to measure the pressure drop between point A and point B using a differential U-tube manometer in order to acquire the volumetric flow rate across the test section of the wind tunnel. So the density of the fluid in the wind tunnel is 1000 kg per meter squared, whereas the density of gauge fluid is 1600 kg per meter squared. Meanwhile, H1 is 1.2 m and H2 is 0.775 m, the column of height. So next is question. So the question is asks us to derive a equation for pressure drop, which means PA minus PB, and then calculate the value of PA minus PB for the given value of fluid density and column height. So for theory and analysis, this case study, the concept of absolute and gauge pressure are explained. So absolute pressure is defined as pressure measured in relation of absolute zero pressure. Pressure measuring equipment, on the other hand, frequently use the gauge pressure, which is measured in relation to atmospheric pressure. At sea level, the standard atmospheric pressure is 101.3 kilo Pascal or 14.7 psi. So when the gauge pressure is negative, it is referred as a vacuum or suction pressure. So from this slide, as we know, the gauge pressure is equal pressure absolute minus pressure atmospheric, and the vacuum pressure is equal P atm minus P absolute. So for calculation, to determine the pressure between point A and point B, an equation must be derived start from the other side to other side, which means the equation will be PA equal to rho 1 GH1 minus rho 2 GH2 plus rho 1 GH1 plus H2 equal to PB. And then we arrange the terms. It will be PA minus PB equal to rho GH2 minus rho 2 minus rho 1. So by referring the value given, we substitute into the derived equation, and we got the answer is equal 4.4 kilo Pascal. So next is discussion. A manometer is made of a U-tube with one end linked to an unknown pressure container and the other end open to know the atmospheric pressure. The gauge fluid in the U-tube manometer may differ from the fluid in container. So the process for determining the pressure inside the container is followed by this step. First, we begin at one end and work your way up to the open end of the manometer, moving from one fluid level to the next. And number 2, for the fluid at rest, remember that pressure increase linearly with depth. So for conclusion and recommendation, Absolute and gauge pressure are important in daily life since its application are essential. So absolute pressure gauge are commonly employed in research and scientific laboratory, where change air pressure might be a problem, as well as the aeronautic, where exact measures are required to establish the altitude. This pressure also includes a number of standard pressure measurement device and technique. Other than that, manometer. Other than manometer, there are other devices that used to measure this pressure such as a barometer and piezometer.